In this lesson, we are going to learn a very important concept called the principle of moments. In this slide, we have two children sitting on a seesaw. The weight of each child exerts a force downwards. There is a turning effect of each of the weights. W1 is exerting an anti-clockwise moment, which is equals to W1 times perpendicular distance D1. Whereas the moment of W2 is a clockwise moment, which is equals to W2 times perpendicular distance D2. If the clockwise moments equals the anti-clockwise moments, the seesaw will be balanced. This is in accordance to the principle of moments, which states that when a body is in equilibrium, the sum of clockwise moments about a pivot is equals to the sum of anti-clockwise moments about the same pivot. Now, when there is more than one force acting on a system, like in this case, there are two forces, there are therefore two moments about the pivot. The resultant moment is computed by adding all the moments in the clockwise direction and subtracting the moments in the anti-clockwise direction. So when the resultant moment is zero, that is, when the sum of clockwise moments cancels out the sum of anti-clockwise moments, then the system will be balanced. Therefore, the principle of moments have two very important applications. First, it allows us to find out if a system will be balanced. Second, it allows us to calculate the unknown force or distance required to exert the force to balance the system. In other words, in exams, questions will be set in either of these scenarios. Now let's get back to studying how to apply the principle of moments to solve problems. So let's say now instead of two toddlers, a little girl now replaces one of the toddlers. If assuming the girl weighs 30 kg and the toddler weighs 10 kg, both are seated 1 meter away from the pivot, and taking the gravitational field strength to be 10 Newton per kilogram, we can calculate the resultant moment, which is the sum of the clockwise moments subtracting the sum of the anti-clockwise moments. This gives us minus 20 Newton meter. The negative sign tells us that the resultant is anti-clockwise, and the magnitude of this resultant moment is 20 Newton meter. Now we know that if we want to balance the seesaw, we have to exert a force on the right hand side. Assuming the force is exerted at 1.5 meters from the pivot, what would be the magnitude of this force F? We can use the principle of moments, which states that when a body is in equilibrium, the sum of the clockwise moments must equal to the sum of anti-clockwise moments. This means that the 100 Newton meter plus the F times 1.5 meter is equals to the 300 Newton meter. Solving this equation, we get F equals to 6.67 Newton. Let's look at this question from GCE O Level Pure Physics exam in the year 2018. An object is placed on a uniform plank with a support at X. The object weighs 400 Newton and the plank weighs 100 Newton. An upward force F keeps the plank level. What is F? As you can see in this diagram, the moment of the weight of the object is in clockwise direction about the support at point X. Similarly, the moment of the weight of the plank is also clockwise about the support at X. But the moment of the force F is anti-clockwise about X. When the force F levels the plank, the whole system is in equilibrium. We have just learned from the principle of moments, which states that when a body is in equilibrium, the sum of the clockwise moments about a pivot is equal to the sum of anti-clockwise moments about the same pivot. Hence, taking moments at the support X, the anti-clockwise moment is F times perpendicular distance 4 cm. The sum of clockwise moments is 400 Newton times 1 cm plus 100 Newton times 2 cm. Solving this equation, we find the value of F to be 150 Newton. To summarize for this lesson, there is only one simple concept you need to remember. That is the principle of moments, which states that when a body is in equilibrium, the sum of clockwise moments about a pivot is equal to the sum of the anti-clockwise moments about the same pivot.